Alright guys, we're going to do one more. We're going to do the cubic root of 64, that's going to be our coefficient, x to the 7th, and then we'll go times y to the negative 6, so we have a negative exponent in there. Okay, now everything stays the same. Okay, we're still going to solve this the same, even though it looks a little more complicated. We're going to factor these things out, and when we factor them out anytime we can, remember we want to get factors that have exponents that match or are divisible by 3, so we can apply that index or that principal root towards that aspect of the radicand. And remember, this is our radicand, right? Okay, so what can we factor out here? So we see 64. When I see 64, I think it's an even number, it's divisible by 2. I see that third root, I think 2 cubed is 8, right? 8 is a factor of 64, but it's 8 squared. That makes it 8 to the power of 2. That's not divisible by 3. So I start thinking, can I split the difference between 2 and 8? And we kind of come up with 4, don't we? 4 times 4 times 4 equals 4 cubed, of course, right? And we like that because it's matching that index real nice. So let's go ahead and check it out. 4 times 4 is 16 multiplied by 4. 4 times 10 is 40, right? Because there's a 10. 4 times 6 is 24. Add them up, that's 64. That's perfect. That's exactly what we're looking for. So we go ahead and we drop that down. We factor that out to a 4 cubed, okay? Now we have x to the 7th. That 7 power isn't going to work for that index right there, that 3. So what we need to do is make that divisible by 3. So we say, well, let's go x to the 6th. Now this x to the 7th says x times x times x times x 7 times, right? Well, this says x times x times x times x 6 times, right? So data is like energy. Energy is never created or destroyed. It's just changing forms. And the data is the same way. We can't lose data, okay? So let's get rid of those underlines. So we need to make this legit, and the way to do that is times x here. So we have x times x times x 6 times, right? Times x, there's 7. So we've accounted for x to the 7th, okay? So we've accounted for it. Now we have y to the negative 6. We can apply that for sure. We can definitely apply. So we'll go ahead and just keep that as it is, and we'll say times y to the negative 6. So it's a cubic root, and we're going to look at this now. We're going to say, okay, now we factored it out. We've made some arrangements that look like they're going to work really nice. So we see this cubic root. Well, 4 cubed, the cubic root of 4 cubed is 4. So we pull that 4 out, right? The cubic root of x to the 6th is going to be x to the 2nd, or what? Yeah, x to the 2nd. Sorry. So we pull that out. Now the cubic root of x, can't really do anything there, so we're kind of stuck on that one. So we skip to the next one. Cubic root of y to the negative 6. Okay, divisible. That's going to be y to the negative 2nd. All right. All right, because anytime we multiply or divide a negative by a positive, it's a negative. So now we've extrapolated 4x squared times y to the negative 2nd out of the radicand. The original radicand was 64x to the 7th times y to the negative 6. Is there anything left in the radicand? Well, sure. We have this x right here, right? So it's the cubic root of x is left. So we end up with 4x squared times y to the negative 2nd times the cubic root of x. So let's see, is there anything else we can do with this? Well, let's think to our rules for exponents, and then let's look at this. I'll give you a second to see if you come up with something here. All right. Let's see. Let's think back to a to the power of negative n. Do you remember seeing this? This is in every math book, right? A to the power of negative n. What does that equal? A to the power of negative n, the way I always remember it is this 1 becomes a numerator and a to the n stays, right? 1 over a to the n. So what does that mean for y to the negative 2nd? Let's look at it right here. Y to the negative 2nd, and let's apply this rule. That negative, I always say that becomes the numerator, y to the 2nd. Okay? All right? Now go ahead and write that, pause and write that down if you need to. I'm going to erase this bit here. Okay, so I'm going to just kind of follow the arrow here. We're going to come up over here for a second. We're going to rewrite pretty much what you see right here. I'm just going to make it a little smaller. So we have 4x squared times, okay. Now we just talked about the rules for exponent when we have a negative exponent, right? So this is 1 over y to the second, right? Right there, right? Now we can write 4x squared as a fraction as well. 4x squared over 1. Now remember, this is multiplication right here, right? So we're going to have to multiply these fractions. Well, we just go straight across, numerator to numerator, denominator to denominator, right? So 4x squared times 1 is 4x squared, 1 times y squared is y squared. So we end up with 4x squared over y squared times, we still got this bit here, we still have to multiply it by the cubic root of x, and we are finished. Alright guys? Alright, cheers, I hope that helped.